Optics. This is my first optics video and it's about polarization. So light is an electromagnetic wave, and from GCSE I'm sure you know all of the electromagnetic waves, you know, radio, microwaves, infrared, etc. What is an electromagnetic wave? It's now the classical view of it, not mentioning photons for the moment, is an oscillating electric and magnetic field. On this diagram I've got the electric field as being vertical and the magnetic field as horizontal, and they oscillate at right angles to each other, and both of those are at right angles to the direction of propagation, which is basically the direction that it's moving in. And in a vacuum, the wave travels at 3 × 10⁸ meters per second, and that's little c, and that's the speed of a light or any electromagnetic wave in a vacuum or in air. It's pretty close to that, 3 × 10⁸ meters per second. Okay, you must be able to use this equation, V equals F lambda or C equals F lambda for an electromagnetic wave, and I suggest you pause the video and do these, and I'll show you the answer in 5 seconds. And you should get them. Be careful with mega and giga and nano. Make sure you've learnt all of them and you know how to put them on your calculator and stuff like that. Now, polarized and unpolarized. Now, a polarized wave, the electric field oscillates in one plane only. You know, I ask my students so many times in tests, what is meant by a polarized wave? The electric field oscillates in one plane only. If it's an unpolarized wave, then the electric field has components in every plane, or you could say it has X and Y components. Okay, it's all over the place. The E field is in all planes. Of course, this is still perpendicular to the direction of propagation. Light from the sun is unpolarized. Light from a filament bulb is unpolarized. Now, polarizing filters, they will absorb one of the planes. So if you have some unpolarized light and it goes through a polarizing filter, then it will absorb one of the planes. In this particular case, the first filter absorbs the vertical plane and lets the horizontal plane through. Then if you have another polarizing filter that absorbs the horizontal plane, then nothing would get through. We call that cross polaroids. You can obviously test if light is polarized or not by looking at it through a polarizing filter, and if you turn the filter through 90 degrees, it should get lighter and darker. Interesting that light that has reflected off water becomes polarized, and if you look at light reflected off water through a polarizing filter and turn the filter, it gets lighter and darker. Uses of polarizing filters. Photographers use them to cut out glare, which is light reflecting off water. LCD displays, for example, on your calculator, there's a polarizing filter in there. 3D glasses in cinemas. When you watch a 3D film in a cinema, you're actually watching 2 films, and one film goes in one eye, the other film goes in the other eye, and they are separated using polarizing filters. And it's also used for stress analysis in components, and I mention that because there's a pretty picture of it happening.